In the main project for this guide, we created a 2-story building by adding design layers as we modeled. However, there's another way to create all of your design layers before you begin drafting, and that's by using stories. This addendum explains how to do it. Just as we did in the previous project, we'll first need to set up our document. In Vectorworks, go to File, New. Choose Create Blank Document and click OK. Once the blank document opens, go to File, Document Settings, Units. Then choose Millimeters from the Units drop-down menu in the Length section. Also, set the Units menu to Square Millimeters in the Area section and choose Cubic Millimeters from the Units drop-down menu in the Volume section. Then, click OK to close the dialog box. Next, we'll change the page boundary orientation by going to File, Page Setup. In the resulting dialog box, click the Printer Setup button. Select Landscape for your page orientation. Then click OK twice to return to the drawing area. We're now ready to move on to setting up stories for this document. In Vectorworks Architect, stories help you organize and control the elevation of all design layers that would make up a building story, such as slabs, finished floors, and ceilings. To create these stories, go to Tools, Organization, and select the Stories tab. Now, click the Default Story Layers button. Here, we can name our default design layers and also modify the parameters to be used by default when creating new stories. You can also customize this list by adding or deleting design layers. For this guide, we'll be using the default layers and just modifying the parameters slightly. To begin, hold the Command key on a Mac or the Control key on Windows and select all of the design layers in the list. Then click the Edit button. In the Edit Default Story Layer dialog box, click the Scale button and choose 1 to 50 to set all of the design layers to this scale. Click OK twice to close the dialog boxes. Next, select just the design layer labeled Floor and click the Edit button. In the dialog box, set the elevation field to 50 and the layer wall height to 0, then click OK. This means that on any given story, the floor design layer will be elevated 50 millimeters from the relative ground of that story. Also, select the ceiling design layer and click the Edit button. This time, set the elevation field to 2800 and the layer wall height to 0 so that the ceiling layer on any story will be elevated 2800 millimeters from the relative ground plane. Click OK twice to return to the Organization dialog box. Now, click the New button to create the first story. Notice in the dialog box that the default story elevations are set with the values we input in the previous steps. From this dialog box, you can also choose which design layers should be included in the story. Make sure the only design layers selected are Slab 1, Floor 1, and Ceiling 1. All of these layers will be created with the default names set in the Edit Default Story Layers dialog box, but a suffix or a prefix can be added to the design layers so that you can easily differentiate the story to which each design layer is assigned. Since this is the first story of the building, we'll leave the suffix set to 1. If this story started below ground, you could change the suffix or prefix to something more appropriate, like B for basement. You can see how all of the design layers would update accordingly. Lastly, you also change the elevation of your story from this dialog box. But since ours should start at ground level, we'll leave it set to 0. Then, click OK to create the story. Take a look at the preview pane to the right. The blue elevation marker displays the name of the story and its elevation. The white elevation marker shows the names of the individual design layers contained within the story and their respective elevations. Let's create another story by clicking the New button. Notice that Vectorworks automatically changed the story name and suffix according to the previous values to Story-2, and a suffix of 2. Also notice the story elevation field was updated based on the elevations from the previous story. However, for your building, we're going to change this elevation to 3100 millimeters. This way, there is some space between the ceiling from the first story and the slab of the second story for adding things like lighting fixtures and ductwork. Once you make this change, click OK to create the second story. You can see the preview pane has been updated to show information for the second story. This pane will show the data for whichever story is highlighted in the Stories pane to the left. Let's add one last story for the roof. Click the New button again. Since this is the last story of the building, the only design layer that should be included is the ceiling layer, so uncheck any other layers that are currently checked. Also, let's change the elevation to 5900 millimeters, as there is no need to create additional spacing because there are no floors going above this ceiling. Click OK to create the third story. Then, go to the Design Layers tab in the Organization dialog box. Remember, when you create a new document in Vectorworks, a design layer labeled Design Layer 1 is created by default. We do not need this design layer, so select it from the list and click Delete. Select Yes from the next dialog box, and make sure that Slab 1 is the active layer. Also notice, the elevation for Design Layer Ceiling 3 is set to 8700 millimeters. This is because the ceiling layers default to be 2800 millimeters above the relative ground plan for a story. However, since we will only have a roof on this layer, it should be placed on the relative ground plane for this story. So select Ceiling 3 and click the Edit button. Change the elevation field to 0, and click OK twice to return to the drawing area. Next, we are going to create the walls for the first story. The walls will be drawn on Slab 1, since they will be bound to the slab we will create afterward. Go to the Building Shell toolset, select the Wall tool, and click the Preferences button in the toolbar. In the Wall Preferences dialog box, select 150 mm generic wall from the Wall Styles drop-down menu. Now, go to the Insertion Options tab. In the previous project, we set up layer wall heights for each design layer so that any walls drawn would be set to this value. However, wall heights can also be determined by the elevation of another design layer. For example, choose Ceiling from the top-bound drop-down menu. This means that the wall's height would be the same as the elevation of this layer, which is 2800 millimeters. Save this wall style by clicking the Save Preferences as Wall Style button. Click OK and Yes to the subsequent dialog boxes to overwrite the original 150 mm generic wall in this file. Then click OK to close the Wall Preferences dialog box. Now, draw a series of walls similar to the one shown here to create an L shape. But be sure your walls are inside the page. Take a quick look at the Object Info palette and notice the height field is set to 2800 millimeters, as the walls are set to Design Layer Ceiling elevation. Next, we're going to create a slab that will be bound to these walls. Select the Slab tool from the Building Shell toolset and click the Preferences button in the toolbar. Choose Floor, Ceiling, Assembly, Generic 300 mm from the Slab Style drop-down menu. Next, select the only component for this slab and click the Edit button. In the Slab Component Attributes dialog box, select Outer Face of Wall Core from the Auto-Bound drop-down menu. Click OK to close the dialog box. Now, save this slab style by clicking the Save Preferences as Wall Style button. Click OK and Yes to the subsequent dialog boxes to overwrite the slab style. Then click OK to return to the drawing area. In order for the slab to bound to these walls, we cannot draw the slab. Instead, we must choose the second mode in the toolbar's Pick Walls mode and click each of the walls. You will know a wall is selected once it's highlighted in red. Next, click the green check in the toolbar to create the slab. And there's our slab. With the slab still highlighted, go to Modify, Send to Back, so we can see the walls above the slab in a top plan view. Let's use the Flyover tool to take a look at the walls and slab in 3D. You can see the bottom face of the walls and the top face of the slab are both at 0. Return to the top plane view so we can create the finished floor for this story. First, in the navigation palette, make Floor 1 the active design layer and set all layers to invisible except Floor 1 and Slab 1. Additionally, choose Show Snap Modify Others from the Layer Options drop-down menu. Then activate the Slab tool from the Building Shell toolset and click the Preferences button. In the Slab Preferences dialog box, select the unspecified component and click the Edit button. Name this component Solid Wood Planks. Also, set the thickness field to 50 mm and choose Inner Face of Wall Core from the Auto Bound drop-down menu, so the floor sits inside of the wall faces. Click OK to close the dialog box. Now, go to the Insertion Options tab and select New from the Class drop-down menu. Name this new class Slab Component Decking and click OK. Also, select Choose Texture and select the Wall Slab Material Solid Wood texture. Finally, select Slab from the Datum Layer ZREF drop-down menu and set the datum offset from the Layer Z field to 50. This means the top face of this floor will be fixed to the slab layer's elevation, but it's also offset by 50 mm, which is this floor's thickness. Therefore, the top face of the floor will start 50 mm above the slab layer and be extruded downward 50 mm, so the bottom face of the floor touches the top face of the slab below it. Let's save this slab style by clicking Save Preferences as Slab Style button. Name the style Solid Wood Planks and click OK twice to return to the drawing area. Just as we did with the last slab, use the Pick Walls mode and select each wall. Then, click the green check in the toolbar to create the floor. You can see this floor was created on the inside faces of the wall just as we specified. In the view bar, switch to a front view and zoom in to the bottom right corner of the model. Here, you can see the top face of the floor is offset 50 mm above the slab layer. If we had left the Z offset field at 0, then the floor would have been beneath the slab. OK, return to a top plan view. In the navigation palette, set the design layer Floor 1 to Invisible and design layer Ceiling 1 to Visible. Also, make Ceiling 1 the active design layer. The reason why we kept design layer Slab 1 visible for the creation of the finished floor and ceiling is because this design layer contains the walls, which are the bounding objects for both the finished floor we just created and the ceiling we are about to create. Next, select the Slab tool again and click the Preferences button in the toolbar to open the Slab Preferences dialog box. Select Suspended Ceiling, Wall Slab Styles Imperial No Code from the Slab Style drop-down menu. Also, from the Components section, choose Mineral Fiber Ceiling Tile and click Edit. Then, set the thickness field to 15 and click OK. Additionally, choose Metal Suspension Tee from the Components section and click Edit again. This time, set the thickness field to 20 and click OK. Now, go to the Insertion Options tab and set the datum offset from Layer Z field to -250. Last, save this slab by clicking the Save Preferences as Slab Style button. When the dialog appears, click OK and Yes to the subsequent dialog boxes to overwrite the original slab style in this file. Then, click OK to return to the drawing area. Just as we did with the finished floor, use the Slab tool in the Pick Walls mode and select each of the walls as the bounding objects for the ceiling. Then, click the green check mark in the toolbar to to create the ceiling. In the Basic palette, use the Flyover tool to get a better view of this ceiling in 3D. Remember, the top of the walls are bound to the ceiling design layer. So, you should notice that the bottom surface component of the ceiling slab, which was selected as the datum, is 250 millimeters below the top of the walls, leaving space for things like lighting fixtures or ductwork before reaching the slab from the stories above. At this point, we've created the first story of our model. Now, let's quickly use the same process to create the second story. First, make Slab 2 and Slab 1 the only visible design layers. Also, make Slab 2 the active design layer. Now activate the Wall tool. Make sure the wall style 150mm generic wall is the current style in the tool. Then, return to a top plan view. Also, set the layer options in the navigation palette to show Snap Others. Then, trace the existing walls from Slab 1 to create the walls for Slab 2. There. Next, use the Slab tool with the slab style Floor, Ceiling, Assembly, Generic 300mm in the Pick Walls mode, and select each of the walls we've just drawn. Once all the walls are highlighted, click the green check in the toolbar to create the slab. Remember to press Ctrl-B on Windows or Command-B on Mac to send the slab to the back. Let's switch to a front view to take a look at what we have so far. You should see the bottom face of the slab we just created meets the top face of the wall at an elevation of 2800 millimeters. This is why we set the second story elevation to start at 3100 millimeters. Since the slabs are extruded downward, and the slab is 300 millimeters thick, the bottom of the slab is at an elevation of 2800 millimeters. Now, switch to a right isometric view. We no longer need to use the objects from the first story as a reference, since we've created the slab and walls on the second floor. So, make Design Layer Slab 1 invisible, and set Design Layer Floor 2 to visible. Also, make Floor 2 the active layer, and set the Layer Options drop-down menu to show, snap, modify others. Again, use the Slab tool. This time, however, choose the Solid Wood Planks from the Slab Styles drop-down menu in the toolbar. Select each of the walls. Then, click the green check mark in the toolbar to create the floor. Next, in the navigation palette, set Ceiling 2 to visible and make it the active layer. Then, go back to the toolbar and choose Suspended Ceiling from the Slab Styles menu. And, once again, select each wall. Click the green check mark to create the ceiling. There. Now the second story is done. Take a look at the model using the Flyover tool, and then return to a right isometric view when you're done. The last thing we need to do is create a roof for this model. So, in the navigation palette, make sure Ceiling 3 and Slab 2 are the only visible layers, and make Ceiling 3 the active layer. Now press the X key to switch to the Selection tool. Hold the Shift key down and select all the walls from Slab 2. Then, go to AEC, Create Roof. In the Create Roof dialog box, set the vertical field to 162 millimeters. Set the roof pitch to 40 degrees. Set the bearing height to 0, and the eave overhang to 600. Once you've made these changes, click OK to create the roof. Now we've completed our model. Let's set all design layers to visible and use the Flyover tool to see the model in its entirety. Once you're done, switch to a top plan view. Now, we're going to create a section viewport of this model. To do so, go to View, Create Section Viewport. Move your cursor along this ridgeline of the roof. Then press the T key to create an extension line. Follow this extension line to the left side of the roof and click once your cursor is outside the roof to create the first point of the section line. Then move your cursor to the right along the extension line and click again once your cursor is again outside the roof. This line is the cutting line for the section view. Now, we need to choose which side to look toward in the section, which is determined by the direction of this black arrow. Move your cursor upward so the arrow points the same way, and then double-click to set the section line. You should notice the Create Section Viewport dialog box appear. From this dialog box, choose New Sheet Layer from the Create on Layer drop-down menu. In the next dialog box, input Section in the Sheet Title field and click OK. Also, set the drawing title field to Section. Next, click the Advanced Section Properties button so that we can change the appearance of this section viewport. Go to the Attributes tab and choose the option Separate Cross Sections. Also, check Use Attributes of Original Objects. These two options will create a separate cross-section for each object on the cutting line, which will be displayed with its original color attributes. Also, go to the Display tab and check the options Show Wall and Slab Components. Then, click OK twice to create the section viewport. We could stop at this point, but let's give this section viewport some depth. To do this, in the Object Info palette, set the Projection drop-down menu to Perspective. Then, set the Perspective Type drop-down menu to Normal. After making these changes, the Update button should appear in red. Click this button to see the changes. Finally, reposition the viewport inside the page boundary and edit the viewport annotations to move the drawing label below the section. We've completed our building using stories.